But oftentimes, the utilities don't really know about these kind of critical areas. We make them visible and enable them then to counteract. On a short term, it's flushing, which is waste of water in quotation mark, but at least it's then safe. And on the mid to long term, it's then really better planning of renewal of the infrastructure, for example, by burying the pipes deeper or reducing the diameter of the pipes.
Welcome to the Urbanista, where we discuss the water management challenges of Nordic cities. From safe drinking water distribution and stormwater collection to building sustainable urban living environments. Here is your host, Delphine Vesalo.
Hey, welcome back, Urbanistas. It is so nice to be back in your ears. After all this conversation we have had with our guests over these years, one concern keeps consistent: water availability. We know all across Europe, we have seen all the issues that water loss is creating, and how can we ensure a consistent supply of good quality water? That's on every water utility mind. So our guest today has been working on this area, specifically in the water monitoring space. So who are you and what do you do?
Hi there. Yeah, my name is Maximilian Oberndoerfer. I'm a product manager at Diehl Metering. A few words about Diehl Metering. It's a metering company. We make meters now for more than 160 years, so quite a long time. And we have been a partner for water utilities as such, also for a very long time. And as you just now mentioned, the issue of water availability, but also the scarcity of water, has become increasingly a topic that concerns, well, us as a company, the utilities, our customers, but then also us as individuals, because we in the end are relying on that water to be available when we need it for daily consumption.
Yes, this has been, as I mentioned at the beginning, it's a constant concern, a constant discussion, and how do we get from the source, whether it's surface water or in-ground water, how do we get it good quality water in a consistent flow, in a consistent manner, and how do we distribute it? And depending which is the stat that you want to believe, I mean, we have interviewed many people here, and the belief is something between 10, 20, somebody even said 50%, 50% of the water that is distributed in Europe gets lost, depending the country, depending different situations. So as I said, depending which is the stat that you want to believe. But this is definitely a key issue that we need to tackle in Europe. So as a matter of introduction, you were mentioning before we went on air some specific case that you have been working on recently. I believe it's in France.
Right. So we had more than just a few customers that we have been partnering with for a long time approaching us. And in particular in France, it's been an issue over the last, I think, 2 years in particular, where they've been really struggling with that. And also now they have national regulations where certain regions are impacted with regards to how much water they can supply before restrictions really come into place. And despite that, still certain towns in France had the case where there was no more water to be sourced from the wells, and they had to drive it in with trucks, which is honestly a very scary thought, relying on trucks like this.
With the consequent, depending, of course, if the trucks are fueled with carbon,
Yes,
with gasoline or with electricity. I mean, this an added pollutant, if you want, but yeah, definitely a big concern. So the moment to act is now. So it's so important that we act now to make the broader public aware of this problem.
it's exactly the point that we see A in the market, but B also we as a company see it as our responsibility to really contribute positively in that space, and first to drive awareness, and secondly to also provide, of course, solutions in collaboration with the utilities in Europe, but also worldwide, to tackle exactly this issue.
And actually, one of your basic proposal that you have at Diehl Metering is this 10-minute analysis. That caught my attention So can you please elaborate more? What is this exactly? 10-minute analysis, and how do you get there?
Right. The core concept of 10-minute analytics really is the idea that, well, as a utility has less and less staff available and less time per staff available, we can't really take out this time and focus on now even bigger getting problems. So the idea is take 10 minutes a day and you're done. In terms of especially what you mentioned initially, focusing on the losses in your distribution system. So that's the part that we currently tackle. And the idea is that you as a utility, you have data available. You have to have data by now. I mean, you have either your SCADA somewhere, or you additionally have data from distributed pressure sensors, noise loggers, you name it. Whatever you have, you can use this, but it might be difficult for any individual to digest the data and come to meaningful results to determine what the course of action at this very moment is. So instead of that, of having this manual or, well, this individual effort, really use a software that does that for you, presents you the results in a way that you can easily interpret what's happening in the network, and then determine what you need to do subsequently. So as said, operator joins his team in the morning. They have a look at the system, 10 minutes. They know exactly, do I have losses? Do I need to act on the losses if I have any? Where are these losses located? And for us, it's also important to then build a knowledge base at the utility over time so that, for example, if any individual retires or falls ill for a certain period of time, that knowledge about the network is retained within the organization so that if future leaks or bursts happen, they can still be tackled.
Actually, that's super important point that you mentioned, because that's what we have seen with different of our customers, that the understanding of how the water network is working sometimes resides in the head of some people, the old wolves that have been working there for years and years. And when that person, that people is no longer there, kind of, yeah, it disappears. So that is super important. I mean, data that is stored, that is processed, but it's not just having volume of data, but how do we understand it? And that's what you are mentioning
Yes.
with this network of pressure sensors. So how does it work in practice? Collecting all this data from different points and then bringing them to some software or some dashboard. Can you elaborate more how this looks?
Well, in the end, the way that it looks like for users is you have your network and it's split into different zones. Usually, district metered areas, DMA is the term used in utility sector, and it's very simple. It's like a traffic light. So the red zones are, well, I have water losses and I need to act now. The orange or yellow ones are, okay, there might be something. I can dig into it if I have the time. And the green ones basically tell me I'm fine. I don't need to be looked at right now. You can focus on the more important tasks at hand. And the underlying, I would say, magic behind really is the combination of different data sources. So we're talking about SCADA. I already mentioned the GIS, so the Geographic Information System.
Mm-hmm.
Where are my pipes? But also how old are they? What material are they made of? All this meta information on the network. Pumps, pumping station, pressure sensors, as said, noise loggers. And then for us as a metering company, of course, importantly, also the billing / the metering data at the end consumer side of things. And all of these more or less are combined. So we retrieve data. We currently do not write data. So no worries. We are not controlling your pumps, your valves, or anything. That's not the purpose what we're doing. But in the end, we take this data and we combine it in a way that we can display this traffic light system on the DMA level. I
Because
can
you're
go on
collect.
talking about this for ages, so please.
No. Yes, no. That's actually the interesting part, that we start to slice and dice all these things. Actually, because you talk about the data coming from the meters
Yes.
regarding the flow. You just briefly mentioned the status of the pipes or the valves. So that information is not collected by your system, or how do we know if this part of the network it has 10 years, is 10 years old, and the other part is 30 years old? So that is provided by the utility, or how, but is consolidated in your system, or how does that work? The status or the state of the infrastructure.
Yes, exactly. That's the purpose here. So the idea is that we take the data that is available at the utility. So for example, in the GIS, if that information is available, and it's not always, I would say, complete, but most utilities nowadays, they have some understanding and also some digital representation of their network. Of course, it can always be better, but they have some level, and we take the level that they have, and based on that, try to, let's say, make it easier for them to make decisions. Of course, we're still, I would argue, in between a transition phase where we have these experts, you call them old wolves, I think, where we have these experts who know exactly, okay, these pipes in this area are maybe 40, 45 years old. And that's unfortunately not yet in the GIS. It's not yet digitally represented. But the more and more they realize, these people, that they cannot handle the complexity anymore and that they don't have enough people to tackle all the challenges being thrown at them, the more they learn to the necessity really of sharing that knowledge, and first of all, well, putting that into a digital system, but then just throwing it into a bucket and leaving the bucket standing around, that doesn't help anybody. So you actually have to take that then out and further digest it and further use it really and make it usable also for the younger generations at the utilities. And that's exactly where we come in.
Yeah, exactly. Collecting data for the sake of collecting and dumping it somewhere without a tool or a person actually making sense from this side of the screen, making sense of what is on the other side of the screen. That could be, because that's super important. So you mentioned that you measure different parameters or KPIs, how you call it. Can you elaborate more? So what is the process? Which are these KPIs that you measure?
Right. So in essence, for the traffic light system that I mentioned, we look at a daily water balance. So that's honestly a very simple comparison of what goes in and what comes out of the water network. And that tells you that it gives you a very good indication, especially if you know very well what's happening on the end consumer side, how many physical losses you have in your network. In addition to that, we call it layers on top of that we also look into. That's, for example, the minimum night flow. So that means how large is my night consumption at its minimal point, where I assume that most of the things that I see are not due to, well, real consumption, but rather losses in the network. And then on top of that, I mean, these are just the KPIs that we do, but on top of that, what we further provide is how well does my data make sense? So answers to that question. Is the data that I get in to my system, is it of a quality that enables me to make decisions based on that? So because if, for example, if I only get 10 out of 100 meters, for example, and I want to do a water balance, it's probably very inaccurate. So this further level that we provide is, okay, is the availability of the data, is it good? Is the quality of the data good? And if these all are, well, given, good. If it's not given, we also try to help our customers in improving the quality over time, saying, okay, maybe you have an area here where you need to use a different connectivity solution for your devices, whatever sensors you have in that area. We get very irregular measurements from your district meter here. Maybe it's time to replace the data logger. That kind of suggestions we also provide on the data quality side of things.
When you now mention the minimum night flow, or I'm taking more like we know at which point of the day there's more consumption from the users, where it's less. So
Right.
that's one parameter that you take into account to if it's supposed to be low consumption at this point, and suddenly there's a peak. Okay, there's no people consuming it because people is sleeping. Clearly, that's how do you deal with events? I mean, in public events, and I'm thinking, I don't know, any given football stadium, which normally, like Monday to Friday or even 2-3 weeks, it's empty. There's no demand of water there. But when 20, 30 to 50,000 people get into the stadium and start to consume water in any shape or form,
Yeah.
drinking or toilets, etc., then it peaks. So even events and things like this you need to consider at some point in your
Yeah.
in your system.
Exactly. So maybe before I go into the details of it, I should say what we're not doing yet is a prediction, because predictions would be heavily impacted by these, I would call them irregular events, right? Unnormal behaviors of a large group of people. What we instead do is we do two things. One, we look over longer periods of time. So a day already is for us quite long. But within a day, you can kind of see, okay, maybe there is a peak in a certain hour, or during, like, let's say, a football game, 1.5 hours, or during the break in particular, which is then a 15-minute peak. Over a longer period of time, that kind of evens out. Yes, the total volume per that day will be larger, but, and that's the second part that we look at, is also that we look at the consumer side of things. So that would mean that, for example, we would be getting the data from the households or from the stadium in this case. We're not interested in the individuals. We're more interested in how does the overall population consume water at a certain point in time. And is that, well, then a physical loss, or is that, somebody actually just using, for example, the toilet flush?
Because you are focusing, I mean, the way you detect the water loss is by measuring the flow pressure. That's basically it. Is there anything that you can do, or is that in your scope, the water quality monitoring? Any particular particle that should not be there, or is just to narrow down? Is it just the flow pressure, or is it something else that you can detect in the water?
Right. So what we currently also do not do, we do not measure quality of the water in itself, for example,
Okay.
biofilm, or what is it called, turbidity. Instead, what we do, and that's courtesy of our meters really, we have an indication of the temperature. So that is a good, how to call it, a good predictor for growth of biological material, where it shouldn't grow, especially above 20 degrees Celsius. And we use this especially during the summer period to monitor parts of the network that might be stagnating too much, for example, because they have over-dimensioned pipes, or there's new tar on the streets that heats up the ground underneath too much, or the pipes are not deep enough buried. Various reasons for that. But oftentimes the utilities don't really know about these kind of critical areas. We make them visible and enable them then to counteract. On a short term, it's flushing, which is waste of water in quotation mark, but at least it's then safe. And on the mid to long term, it's then really better planning of renewal of the infrastructure, for example, by burying the pipes deeper or reducing the diameter of the pipes when they are being renovated.
Actually, yeah, quite insightful data. So even you have all this historic, when this is the time to renovate whatever part of the street of the city, you may already have certain parameters of certain clear idea what to do before even bursts or before even digging.
Yeah.
So actually that's a nice and another good thing to have this historical data to prevent, or to, I don't know, calculate, or to start calculating the future project, renovation project. So in summary, so the water network manager, that's the way that they can benefit from your technology. So knowing what is happening in real time, and then the water network manager or the person in charge being able to act like immediately. So what are the actions that they are taking that you have seen?
Well, the actions that we've actually seen is that often, I mean, on the one side, we usually start with a project where people then realize, okay, maybe the data quality can be improved. And then we help them improving the data quality until a point where they say, okay, you know what? Okay, this shows me a situation about my network that I wasn't aware of. Oftentimes we come into this kind of scenario where I wouldn't call it, I would call it that people maybe are not aware of the losses that are actually happening out there. And when you provide this level of transparency, all of a sudden something clicks, and these customers, these utilities then decide, okay, we need to act, and we can easily prioritize where are the areas that we need to act upon first in order to see immediate impact. And oftentimes that results in, well, going out, localizing the leak. So where's the exact location of water loss, and starting with the larger ones because usually they're easier to detect. Sometimes there are some tricky situations that I've also come across, but usually they're easy to detect. And that's one of the things that we are now also diving deeper into. I'm not sure you have heard, but we have acquired recently another company called Provencio, and it's exactly their expertise. They focus on locating leak location. So basically identifying where in a pipe segment do I need to look, which really reduces the search time and makes it a lot easier to deploy teams and, for example, directly start with correlators on a certain noise correlators, that is, on a certain
How
segment of.
precise that could be? I mean, down to few meters or in one given square. Okay, is this
Right.
happening in the square? If the square is like 15 meters per 100 meters, like that's still a big surface for the crew to go on. How
Yes.
precise that could be, really?
So it really depends on the coverage of sensors. If you have a lot of sensors, of course, you
Yeah,
can be very
right.
precise. There were cases in the past where this in water was about 10 meters of accuracy, which is like before going out with noise loggers, stellar. I think you cannot get much better with that approach. More realistically, we're looking at a reduction to about a kilometer of pipes. That's then multiple pipes still to be checked. And we had a case study as well where we tried that out with a customer, and they started 2 zones, 42 kilometers roughly of pipe length. And with this approach, only 1 kilometer was left to be searched. And actually, the leak was located in one of these pipes that were still highlighted. It can be even further narrowed down. So right now, I was describing a scenario where you have 2 pressure and flow sensors with very high resolution. That's it. But if you also cover the end consumer side of things, as we often do with our customers, where we say, okay, what consumption is happening where and when, and then we could narrow it down to 600 meters. So it was a singular pipe left, basically to be checked, and it was right at the beginning, so the crew got lucky, but it was just 600 meters left of search space.
I mean, that's already a big improvement. I mean, definitely just reducing less than a kilometer, several hundred meters. I mean, that's already a very good start for any maintenance crew that instead of just keep brushing kilometers and kilometers of pipes. I mean,
Right.
come on, that's already a very good start. And of course, what comes to the resources deployed, the man hours,
Yes.
the material, the equipment that they may carry, faster to locate and to hopefully to repair or to fix what they, and then off to the next one and off to the next one. So that is actually a very nice productivity improvement for the field teams. So that is actually that would be one of the key benefits. I mean, saving or optimizing the resources that any water utility has out there in the field. And one thing leads to another, But hey, that's a very concrete benefit. So we are talking about software and software that collects data to aggregate to present in a nice way, in a logical
Right.
way. This all implies, yes, digitalization. Couple of things. Have you experienced certain reluctance for certain customers in any given country against digitalization for fears of whatever you may think if it is in their internet can be stolen, can be hacked? So that is one. My first question about digitalization, and second, well, it's on everybody's mouth. AI, artificial
Of course.
intelligence. Anything that you can share about that?
Of course. Yes, let me start with the first point with the reluctance and the pushbacks that we might encounter. And I would say it's usually due to the regulatory environment. So yes, we do encounter that, and especially with recent EU regulations like NIS2 being one of the often quoted ones. Utilities are, for the most part, I wouldn't say that they're scared. I would say it's just not so sure what that really means and rather play on the safe side than being sorry. And I completely understand that, if I'm being honest with you. It's not always easy to navigate the regulatory boundaries. For us, it's important to then really work together with these customers. And oftentimes it turns out that, okay, together with having very transparent documentation, with also showing, okay, this is the regulation, this is the actual text of the regulation. It says here you can still use it. It just comes with certain, how can I say that, security or safety requirements that actually help you as a utility in the long term, that we have to both fulfill these requirements, that they then slowly but surely begin to see, okay, it's actually still beneficial, sorry, for me to go down that road. So it's harder to get started, but it's safer in the long term, and it's not impossible. It's not blocked by any of these regulations.
Okay, but yeah, understandable for all the
Yes.
potential risks, the legislation, and taking into account that any water network, any water facility is a matter of public security, definitely. So
Yes.
yeah, that's super important. All right, AI.
Sorry, just
What
one
can
point
you say?
about
Oh,
one point
sorry. Yes.
about the previous one,
Yeah.
because it's very funny to me, because just before Christmas I had the chance to sit down together with some of the utilities in Ukraine, who came over to visit us, and it's of course, a very unique situation that they are facing. And funnily enough, most of them were very keen of using cloud services, because for them it's quite the opposite. They say it's safer for me, it's more stable for me to rely on something that may be distributed for obvious reasons. So just that as a hint.
There you yes, whoa, there you go. And also before, also you mentioned a couple of references or case that you have that would be very nice if we have the link that we can include in the show notes for later people
Perfect.
who can click and go there to read more about any specific case or reference that you have, if it is publicly available, of course.
Awesome. Yes. All right. Sorry for addressing that
No, no, yeah,
quickly.
yeah, 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 please.
But now I can move on to the artificial intelligence, and yes, that is on everybody's mind and tongues, I should say. It's a widespread word, and I I like to think that we, on quite contrary to what many people are doing out there, we actually only try to talk about this when it actually brings a benefit, right? Because in the end, you can achieve many things with, I would say, traditional mathematics, statistical approaches, for example, even in forecasting. But when I think about broader digitalization trends, what we as a company see is the trend for Internet of Things in general, which all of a sudden provides an abundance of data. So before that, we talked about SCADA stations, and yes, we have a very high resolution. We know where very distinct points in our water distribution network, how they function, what's happening there. But now we suddenly know what's happening in the entire network, and an unforeseen resolution, and that becomes really hard to handle. And then if you talk about quantity of data, AI can play a good role. For now, let's say it's not always necessary, but it's a good to have it in the back of your hand. The other thing where AI, for us at least, comes into play is when we talk about hydraulic modeling, and not just about, in quotation marks, the static hydraulic models that are often used in planning of and setting up, for example, new districts, or separating your network into different district metered areas, or just understanding where you might need to renovate for example, for fire safety, i.e. hydrant supply, but rather bringing them into a live application. So that means that you constantly feed them with this data that you get from your IoT sensors and recalibrating them regularly in order to understand, okay, this is my model, and then this is reality, and how does that match together? And then on top of that, kind of analyzing or evaluating this model really for example, where are my leaks? And that's also where I think artificial intelligence can play a crucial role. It doesn't always have to.
But anyway, as you said, it's there in the back part, so we can always get a hand of it to reinforce to support what you are doing, or what the human brain is actually doing, or deducting, or concluding. That's, I guess that's a very clever approach, not just as in many other fields, just let the AI to do the whole job, and then we just wait and watch and wait for the results. Yeah, quite clever. You were mentioning before, when we were preparing this, one very concrete case that you have. I believe it's in Denmark,
Yes.
of the benefits, of how in reality your system and the benefits that has was like implemented in reality. Can you please take us through this case?
Of course. Yes, we're here talking about the city of Brønderslev and the north of Denmark, really. Not not a big city, but still a town that supplies, I think, 20,000 inhabitants. And the situation, I should say, was that in 2017, 2018, the utility there faced very high water losses for Danish standards in particular, which was on average more than 14%. The numbers differ, but on average, about 14% of the water supplied was being lost. And what we need to understand really is that in Denmark, there is a very strict regulation. If you have losses that are larger than 10%, you pay hefty fines. So there was a real pain to act upon that. And what the utility company then decided to do, okay, installing DMAs, but also installing smart meters and the connectivity solution for them. So getting really the data, building that database. But then they quickly realized, okay, having that data is good. It's a good start, but it's only a start. So utilizing this data then became crucial. And that's exactly where I would say myself and the team came into play. And we were lucky enough to work together with them on a solution. And they've been using our 10-minute analytics, our water loss management dashboard for now years. And the most recent numbers of last year was that the water loss is now at 4.5% on average. So reduction that's quite significant.
From 40%
No,
to
14.
4.
Sorry, 14 to
Okay.
4.5. Yes.
Well, but still, I mean, that's
Yes.
a huge improvement anyway. Less than half. I mean, way less than half.
Yes. Of course, it's not only due to us, but we are very happy and I'm personally very proud to help the team, the local utility to fight that fight. And it's very inspiring also to me that they say, okay, we're at 4.5%. That's, most utilities would say good enough. Not for them. They say we can do better. And it's really fun to help them honestly strive for getting better day in and day out. So the way that they really work nowadays is they come into the office, they open the dashboard, they have a look, they say, okay, is there a red zone? If so, yes, I'll have a look. What are the losses? Do I need to act now? Yes or no? How's the night flow looking? Is the data quality all right? And then they also use basically a statistical analysis of how likely it is for a certain pipe to break. And that's where they start looking. And we're hoping to be soon also providing them with the live hydraulic model. But that's still in discussion. So in the end, they're very well equipped from I would say, the infrastructure point of view. We help them with our solution, but for them it's also crucial, and I can only mirror that sentiment, that they have the people who really are interested in the data and in using data to get better every day.
So because listening at this whole case, let me say what was the key trigger for making this happen? Okay, the 40% water loss, that's already important enough. But in other cases, in other cities where that may not be that high, so would you say that is the people, the willingness really to tackle the problem and to get the thing done? So would you say that is more like the forward-looking people that is behind, or what would you say that was the key success factor for this case?
Right. I think we as an industry are still. I don't think it's a stretch to say we're rather traditional in water, and we're slower to change than maybe other fields, other industries. Look at the whole AI bubble, for example, who are a lot faster, iterating a lot faster. And because it's critical infrastructure, I understand the need for taking the safer route. That's perfectly fine. In this case, though, still you occasionally need to take risks or be forward thinking, as you mentioned. And yes, for this customer in particular, I can definitely say that the people that I have the pleasure of working with, they are of this forward-thinking nature. However, the beautiful thing that we now can see is that because they are taking these steps and they're learning and we're learning with them, and now others can, learn from them. And we've had people come up there and look at how they run operations. As I said, it's not the biggest utility, but because they are a little bit ahead, it's also not a stretch to say they're a little bit ahead of other utilities. They're now kind of, really sharing their experience, which enables then others to take the same steps or steps in a similar direction, which really brings the whole industry forward into a direction that is very well necessary. And for us, also, honestly, a beautiful development to just watch.
What I'm realizing is that, as you say, okay, it may be the initial trigger from the owners of the network, but this is definitely a collaborative work. Yes, from your side, providing technology, specifically addressing the problem, empowering them, right? The technology that empowers them to find the problem. Then how do we repair? How would we source all these materials? And it's really a collaborative effort amongst all, many players in the industry. It will be super interesting also if this is, if this case information is available, publicly available, that we can also link it in the show notes. The good things. Let's give voice to these good things. Let's spread the good information. So to wrap up, whatever you are able to share, what's coming? What's the future from Diehl Metering? Anything that you can hint? How do you see this whole technology evolving in the future?
Right. Two things that I already mentioned, but I think we will still focus on. One is the part of really being able to localize leaks, i.e. giving better recommendations of what you should be doing and also when you should be doing those things, and not necessarily telling you, okay, this is the list of 100 things you can do, but rather saying, okay, today we think this is the one, or these are the two things that you should be doing. The rest, you can tackle later. And the other thing is when it comes to water quality, and in particular the water temperature side of things, where we see still quite a lot of potential, because it's an underrated, I would say, information that is sometimes and maybe oftentimes available, but just not used to its full potential. And here we're also talking about certain anomalies that we can see in networks, also down to, and that could further enrich, for example, leakage localization, but other things as well, and just improve the overall, I would say, safety of supply for all of us.
There you go. So thank you, Max, for your time, for sharing your wisdom and explaining us more in detail what your technology can provide and can empower the water utilities, the network managers to do. So thank you so much, Max. We hope that we can repeat this conversation whenever you have any update, any new development. It will be super nice that if you, I don't know, some months from now, come back and share what has been your experience or where are we going.
I would gladly do this. Thank you for having me.
That this would be super nice. And yes, thank you for listening today, Urbanistas. You heard it. Technology is here to empower you, to support you, not to substitute any AI, as Max said, it's just to have it there in the back and empowering you to make the best decisions. Thank you for listening, Urbanistas, and see you next time.
Thank you for listening to the Urbanista podcast, a production of Uponor Infra, the leader in sustainable infrastructure solutions. If you found it interesting, why don't you share it with your colleagues? We all together can move our industry forward.